A very good morning to all. On behalf of the Organizing Committee of International Conference on Advances in Tribology 2014, ICAT14, I deem it a pleasure to extend a very cordial welcome to all the dignitaries, invitees and the delegates on the occasion of inaugural function of ICAT14. Now, I request the coordinators of ICAT14 to escort the dignitaries onto the dais. Before we commence our program, let's observe a minute's silence in the memory of our BTech second year Computer Science Engineering student, Mannan Venkateshwaralu, who met with a tragic accident on 15 Feb 2014. Kindly rise. Please be seated. Thank you. Prayer infuses strength, courage, and joy in all our hearts. Let us begin this auspicious ceremony with the invocation being rendered by Ms. Priyanka Yadav. Kindly rise for the prayer. Keyurana vibhushayanti purusham Harana chandrojvala na snanam na vilepanam na kusumam nalam kritamodvaja vane kashamalangkarodi purusham ya samskruta dharyate ह्रियन्ते खलु भूषणादिशतकं वाग्भूषणं भूषणम्. Thank you, Priyanka. A famous quote by William Shakespeare goes, "Small cheer and great welcome makes a merry feast." May I request Dr. K. Prabhakaran Nair, Principal Coordinator, ICAT14, to deliver the welcome address.
Respected Chief Guest Padma Shri Dr. S. Ramakrishnan, Director of Vikram Sarabhai Space Center, Professor Bandyopadhyaya, Director of NIT Calicut, Distinguished Professor KBM Namboodiripad, Professor P.K. Rajendra Kumar, Professor M.L. Joy, distinguished invitees, press and media officials, and dear delegates, members of faculty, non-teaching staff, and students. Good morning to all of you. This is the first time in the NIT, the Tribology Group of Mechanical Engineering Department of NIT is organizing an international conference on advances in tribology. Initially, while we were planning to conduct this conference, we were doubtful whether we will get good contributions from researchers, scientists, and academicians, and from sponsors. Since Asia Tribology Conference organized by Tribology Society of India would also be taken place during the same period. But surprisingly, we could receive a large number of contributions from researchers, scientists, and academicians, and various sponsors have also come forward to sponsor for this conference. We are very thankful to all contributors and sponsors. The details about the conference will be given by Professor P.K. Rajendra Kumar. We have tried our level best to make this conference a memorable one, but recently Institute was closed due to agitation students. Therefore, only less number of students, volunteers are available for your help. Please bear with us. I am coming to my duty. Today, the well-known distinguished scientist of our nation, Padma Shri Dr. S. Ramakrishnan, is with us for the inauguration of ICAT14. And we are fortunate to get such an eminent scientist for inauguration of this conference. It is my privilege to give a brief introduction about him. Padmasri S. Ramakrishnan did his MTech in Aeronautical Engineering at IIT Madras during 1970-72 and passed out with a first rank. He joined ISRO in August 1972 as a member of the SLV-3 project team responsible to develop the first Indian satellite launch vehicle under the leadership of Dr. APJ Abdul Kalam. After successful completion of SLV-3 project, he worked in the Polar Satellite Launch Vehicle program, where he played a key role in the development of liquid propulsion stages, and as a deputy project director, he was responsible for vehicle engineering, integration and launch operations of PSV development flights D1, D2 and D3. He was designated as project director, PSV continuation program in March 1996, and under his leadership, the PSLV was operationalized, enhancing the SSPO payload from 900 kg to 1,500 kg. He was mission director for PSLV C1, C2, C3 and C4 missions and accomplished the first multi-satellite deployment as well as the first GTO mission using PSLV. In October 2002, he assumed charge as project director for the next generation launcher, GSLV Mach-3. In the year 2007, he was elevated as director at Vikrant Sarabhai Spender, and he played a key role in the PSV C-11 Chandrayaan mission accomplishment. With effect from January 2013, he is the director of Vikrant Sarabhai Space Center, the lead center for launch vehicles development at ISRO. He was actively involved in the planning and execution of recent PSLV C-25 mission to Mars by ISRO and functioned as an expert reviewer for the spacecraft propulsion system design and operations. As a member of the pioneering team in ISRO involved in Indian launch vehicles program, Padmasri Dr. S. Ramakrishnan has significantly contributed in the area of propulsion systems development, launch vehicle engineering and project management. He is recognized as one of the veterans and a leading professional in the ISRO launch vehicle community. He has been honored with awards such as Astronautical Society of India Award for Rocket and Related Technologies, Dr. Varun Roy Award for Operationalization of PSV, Padmasri in the area of Science and Engineering from Government of India, ISRO Performance Excellence Award, National Design Award from Institution of Engineers, and ISRO Outstanding Achievement Award. He is a Fellow of Indian National Academy of Engineering, Fellow of System Society of India, Member International Academy of Astronautics, Vice Chairman of International Academy of Astronautics, Commission 3. When we approached him, he readily accepted our invitation to come over here and inaugurate this conference. On behalf of all of you, on my own behalf, we extend a hearty welcome to our Chief Guest, Padmasri Dr. S. Ramakrishnan, to this function. Our director, Professor Bandyopadhyay, is an eminent person and he has a lot of administrative experience. Before joining this institute as director, he was the director of National Institute of Technology, Kurukshetra. He is the author of several books and has given a lot of contributions in the field of electrical engineering. He has given financial and all administrative supports to organize this conference. On behalf of all of you, on my own behalf, we extend a hearty welcome to our director. Today, on the dais, we have distinguished Professor Dr. K.B. Namboodiripad. He was serving in our institute at various academic and administrative positions. He was serving our department more than 40 years, and in 2008, he retired from our institute. When he was here, and now also he used to encourage our faculty members to conduct various professional activities. He has given a lot of contributions in the field of mechanical engineering. On behalf of all of you, we extend a warm welcome to him. Dr. Alessio K. is the head of the Department of Mechanical Engineering of this institute. He has been continuously giving all the support to make this conference a grand success. On behalf of all of you and my own behalf, we welcome Dr. Alessio K. to this function. Professor P.K. Rajendra Kumar and Professor M.L. Joy, Dean of Students' Welfare, are the coordinators of ICAT4. On behalf of all of you, I welcome to this function. Of the dais, many invited speakers are there. Dr. Kim is a professor of School of Mechanical Engineering, Wonsoi University, Korea. And he is also the director of Center for Nanoware. He has attended Asia Tribology conferences. After that conference, he immediately started to come over here and deliver lecture in this conference. On behalf of all of you, I welcome Dr. Kim to this function. Dr. Hakan Kaleli is the professor of Yildiz Technical University, Istanbul, Turkey. He has given a lot of contributions in the field of tribology. He will also conduct an art exhibition which will be useful to all tribologists in this conference. We take this opportunity to welcome him to this function. The distinguished tribologist, Dr. Harish Rani is with us. He is associate professor from Indian Institute of Technology, New Delhi. In the field of tribology, the contributions given by him are tremendous. His research interests are active magnetic bearings, rolling and heterodynamic bearings, and seals. When we contacted him, he readily agreed to come over here and deliver talk. On behalf of all of you, I welcome Professor Harish Irani to this conference. Dr. Bobji is Associate Professor in the Department of Mechanical Engineering of Indian Institute of Science, Bangalore. He is a well-known tribologist. His research interests are small-scale material properties, nanomechanics, nanoparticles in tribology, and surface microstructuring. And he has given a lot of contributions in the field of tribology. On behalf of all of you, I welcome him. Professor Satish V. Kailas, Professor of Indian Institute of Science, who is one of the keynote speakers. He is not present now. He will reach afternoon. For chairing technical sessions, the esteemed bearing company Escape has sponsored three eminent personalities. Mr. Sunil Mandam, Head of the Department, Engineering Research. Then Mr. Ajay Tanwal, Head of the Department, Center of Excellence for Small Cars and Bearings. Shivakrishna Chandra, Head of the Department, Product Development. And we have also invited many professors for chairing the sessions. On behalf of all of you, I welcome all of them to this conference. On behalf of all of you, I would like to take this opportunity to extend our hearty welcome to our press and media officials. And finally, I welcome our faculty members, staff and students and everyone to this function. Thank you.
Thank you, sir, for welcoming the gathering. Now, may I request Dr. P.K. Rajendra Kumar, Coordinator ICAT14, to provide us an insight about the conference.
Respected Chief Guest, Padma Shri Dr. S. Radhakrishnan, Respected Director Professor Raman Bandyopadhyay, Dr. Aleshu, Head of the Department of Mechanical Engineering, Dr. K.B.M. Nambudipad, Dr. K. Prabhar Nair, Dr. M.L. Joy, eminent keynote speakers, participants and chairpersons of various sessions of the conference, press and media personnel, faculty, staff and students of the Institute, and all other dignitaries on and off the dais. It is my pleasure and privilege to talk to an elite gathering of eminent scientists, engineers, and specifically tribologists around the globe on an occasion like this. Control of friction and wear and proper choice of lubricants and lubrication processes in machinery are now known to be the major factors in saving energy, material, and money in the industrial world. Hence, tribology studies and research can be really detrimental in maintaining and improving the world economy. Exchange of knowledge through conferences in this area is all the more important in developing new and more sophisticated methods and processes in tribology. The idea of this conference, ICAT14, was conceived based on these aspects. Further, this conference is intended to give a chance to the faculty and students of our institute to participate and listen to the latest developments in tribology through direct interactions with eminent tribologists around the world, thereby giving newer directions to their own studies and research. I shall now pass on to my duty of briefing the salient features of the conference ICAT14. Through notification on ICAT14 website, we had received about 200 abstracts online from different parts of the world. After review, about 120 of them were accepted for presentation in the conference. We received papers from reputed institutions and organizations such as IITs, NITs, ISRO, SKF, etc. from India, and also from several well-known institutions abroad. We have now delegates from South Korea, Poland, and Turkey, and also from various institutions and organizations in India. There are altogether 13 sessions for the conference in different areas of tribology, such as ball and roller bearings, friction and wear, lubrication, etc., for the delegates to present their research papers. Apart from that, there are 5 plenary sessions in which keynote addresses will be delivered by eminent tribologists from India and abroad. We have 4 parallel technical sessions, today 6, tomorrow 3, on Monday also 3. Each session is chaired by eminent personalities from India and abroad, and gold medal and certificate will be awarded for the best paper in each session. Breakfast, lunch, and dinner are served to the delegates and officials of the conference on 22nd, that's today, 22nd, 23rd, and 24th. On 22nd, that's today, after the technical session, we have arranged some cultural programs presented by the institute students at 6:15 in the evening, followed by a special dinner at about 8 p.m. On 23rd, that is tomorrow, after the sessions, we have professional performances of various traditional art forms of Kerala by a group of artists from a well-known, from the well-known Kerala Kalamandalam, a deemed university of art and culture under the government of Kerala. On Monday, the 24th, after the technical sessions and the valedictory function too, we have arranged a sightseeing trip to the Banasura Sagar Dam, which is the largest earthen dam in India and the second largest in Asia. It is an ideal picnic spot with a beautiful view, and interested delegates can go for a boating also in the lake. Regarding the conference proceedings, we had planned initially to publish the conference proceedings through the Nova Publishers USA. However, this could not be materialized due to some technical reasons. The proceedings are now published by an emerging international journal, Technology Letters. The e-proceedings will also be published by them. The conference has been sponsored by the Ministry of Human Resource Development through its TechIP program, the Department of Science and Technology, CSIR, Magnum Engineers Bangalore, SKF, and Bharat Petroleum Corporation Limited. There are 3 scientific exhibitors too for the conference. I hope that the delegates and other participants of the conference will get benefited from various presentations and the interactions that follow. Wish you all a good time in the institute for the next 3 days, and thank you. Thank you very much.
Thank you, sir. Now, I would like to request Dr. Alleshu K., Head of the Department of Mechanical Engineering, NIT Calicut, to brief us about the Department of Mechanical Engineering and its activities.
Dignitaries on the dais and off the dais, ladies and gentlemen, good morning to each one of you. It is indeed a great honor to the Department of Mechanical Engineering to host this great conference, ICAT14. I take this opportunity to congratulate Professor K.P. Nair, Principal Coordinator, Professor Rajendra Kumar and Professor Joy, Coordinators, and members of their team, including faculty, staff, PhD, PG, and UG students. They have put large amount of effort in planning and coordinating the activities of the conference. It is happy to note that a large number of researchers from India and abroad have come to deliberate on the topic related with the tribology. Many luminaries are present at this inaugural function. All this make the conference a true international and grand one. A few words about the Mechanical Engineering Department. The department offers two BTech programs, one in Mechanical Engineering and another in Production Engineering. There are 6 PG programs with a specialization in Industrial Engineering, Thermal Sciences, Manufacturing Technology, Energy Management, Material Science, and Machine Design. And PhD programs are available in all these areas and related areas. The intake to the UG Mechanical is 140 and that for production is 60. For PG programs, the intake is 20 per program. More than 60 PhD scholars are there in the department. The total number of students attached with the department comes about 1,300. About 50 faculty members, including ad hoc faculty, and nearly equal number of lab staff are also present in the department. We have very good facilities in all the major fields of research, and you are welcome to all our labs. On behalf of the department, I wish you all a very nice days at NITC, and I wish great success to this conference. Thank you.
Thank you, sir. To deliver the presidential address, here we have between us our beloved director, NIT Calicut, Dr. M.N. Bandyopadhyay. May I please call him upon to share a few words?
Our respected chief guest of this seminar, respected Dr. Nambudipad, respected head of the Department of Mechanical Engineering, our respected professors Prabhakaran Rao, respected Professor M.L. Joy and respected Professor Rajendra Kumar, and all the respected professors present here, ladies and gentlemen, and my beloved students. This international conference seminar is being organized under the banner of this TQIP for the technical development of each and every technical institutions. Regarding the seminar, the most important thing, we are getting an idea how the technology is progressing and what are the different developments are being held slowly and very efficiently. For example, that all the mechanical developments, there are lot of change and lot of developments are going, and that is being considered as most of the important development even in the NITC, because in NITC also lot of research are going on this subject, this tribology. And Professor Prabhakaran Nair has made a lot of guidance and research on this particular field. So NITC is progressing like anything. In this seminar, what we have to most importantly think, that is Aristotle has told that quality is not the act, but it is a habit. Quality we have to improve, but there is no formula for the quality development. So we have to inculcate that habit. That habit we have to develop by ourselves. And in this type of seminar, we can think about this, and also interdisciplinary subjects we can discuss how that can be optimize the system with different constraints. So that is why we have to take special ideas and thoughts, and in this type of seminar it is possible. Of course, the most important thing is the knowledge. Foundation of knowledge must be laid through reading. General principles must be had from book, which however must be brought to the test of real life. It is told by Johnson. So what we have to apply, that is the test of real life. That is we have to consider, and we have to proceed like this way. In this type of institute, research is the most important thing, and how this research is to be developed, each and every professor has to think on that line. History makes men wise, poet witty, that is told by Bacon. History means the data which we are collecting, and every day what are the technological changes we are gathering, that is the history. And poetivity means that when a poet writes a poem, he becomes imaginative, and from his imaginative ideas and thoughts and innovative ideas, he is writing the poem. Similarly, all the professors work like a poet and develop something new, some new concept on this particular topic, and that is why this seminar is of immense importance, because from this seminar we expect that some of the new things will come out, and that will be utilized in the industry, because most important thing is the utilization of our ideas and thoughts in the industry. And for this we have to think, and patents and other things are to be developed on this particular field. This particular field is already being developed a lot, and there are more scope for its development. And since we have some great professors in this institute, so students should take the advantage of that, and they should develop that one. And that should be actually the motto of the institute for developing this type of work, and also to conduct this type of seminar and conference. Now, at the same time, we have to remember that education is the discipline for the adventure of life, that is told by Whitehead. Education is the progressive discovery of our ignorance, that is told by Will Durant. And education is a succession of eye-opener, each involving repudiation of some previously held belief, that is told by Bernard Shaw. These are the things we have to remember, and accordingly we have to proceed. We will be really successful, and that will give us a great pleasure. So that's why we have to develop this mind setup. That's why it is told that object of education is to develop the mind, and mind should be the thing that works. That is told by Serud. And on that line, on developing that mind, we have to progress ourselves. Already this institute is progressing in this particular field lot, and we expect that with this seminar and conference, more progress will be developed. And since many foreign delegates have come, they can give their thoughts and ideas, and we can share that one, and we can develop ourselves. That is our great advantage. So we must encash that one and try to develop this institute to a higher level. And research, and particularly that innovative research, is the most important thing. The principal goal of education is to create men who are capable of doing new things, not simply repeating what other generations have done. That is told by Jean Piaget. So something new we have to develop. That means not just that what old has been done, that we have gathered as our reference, but something new has to be developed. So interactions with the foreign delegates is very much necessary, what they are developing in their country. And then we can have to synchronize with their development, and we have to proceed on this particular, the line of the development, and we will proceed in this direction for the betterment. And we have to always remember, we live in deeds, not in ears. We live in thoughts, not in breaths. We live in feelings, not in figures on a dial. On that philosophy, we have to proceed. And then this is actually the duty of the teachers, to study and share the knowledge to each and every one. It is the supreme art of the teacher to awaken joy in his creative expression of knowledge, that is told by Einstein. That we have to remember, and accordingly we have to proceed. Since the time is very short, I am not going to give more lecture on this line. So I hope that this particular seminar and conference will give us a new path for the development of technology in this field, and everybody should be serious enough, and what they have gathered from this seminar, they should assess and analyze, and accordingly they should proceed for the future development of the institute and the country as well. Thank you very much.
Thank you, sir, for your words of wisdom. Light is a shadow of God and symbol of truth. I am extremely privileged and honored to invite our chief guest, Padma Shri Dr. S. Ramakrishnan, Director VSSC Trivandrum, and I also request other dignitaries on the dais to proceed towards lighting the lamp and inaugurate the ceremony. We are extremely happy to have an eminent personality amongst us. I cordially invite our chief guest, Padma Shri Dr. S. Ramakrishnan, Director VSSC Trivandrum, to deliver the inaugural address.
Dr. M.N. Bandyopadhyay, the Director, NIT Calicut, Dr. K. Prabhakaran Nair, Professor and the Principal Coordinator of ICAT14, Dr. P.K. Rajendra Kumar, Professor, Dr. Alesu, Head of the Department, NIT Calicut, eminent teacher and Professor Dr. K.B.M. Nambudripad, the distinguished guests from abroad, the delegates for this unique conference on tribology. I understand it's the first conference being organized here on this subject. Professionals working in the field, students. I'm indeed very happy to be here amongst you today to be part of this international conference. But I'm not a specialist on the topic. I am a mechanical engineer and then an aerospace propulsion engineer. And of course, I happened to see yesterday the souvenir and the document. I saw that the organizing committee, not organizing, advisory committee chairman is the person who coined the word tribology, right? I wish he were here. I would have liked to meet him. Because tribology itself is, I don't know, it would have been practiced since civilization began, or when I can only imagine when the first locomotion started, even without the invention of wheels, even as a animal-drawn sledge, one should have become aware of the friction, the role of friction which is played in locomotion. And of course, with the invention of wheel, what should be made to make it rotate freely? One should have thought of it. And, coming from space, I have always started any lecture on propulsion by saying, locomotion on Earth requires interaction with another body. In fact, all our locomotion is by interfacing with another body, because any change of momentum, you need another body to which you have to exchange. When you go to space, you don't have anything to interact with. And that makes the propulsion in space more difficult, because you have no body to which you can transfer momentum. So you have to carry the mass and push it out to transfer momentum so that you get momentum in the opposite direction. That's the principle of reaction. And that's in fact the limitation of space propulsion. We'll see it later. So as such, this is a very old science, but which has been recognized as a discipline. Maybe recently, I have read some, I tried to just pick up some data on that. Somebody says it is 4 decades, 3 decades, 5 decades old. This has been recognized as an important field of engineering. But then, of course, everyone agrees that it is not having, as an engineering, as a special branch by itself. It is having a role in every branch of mechanical engineering or every branch of machinery. And it's multidisciplinary, a collection of various disciplines, and it's a supporting field which is involved in any kind of mechanical systems with kinematics. And this now the new name coined for the elements which enable relative movement between the bodies is called tribo-elements. And when we talk about tribology, we are looking at defining the science, the physics, the chemistry of making these tribo-elements more efficient, wear-resistant, long-lasting, and whatnot, everything. When you talk about engineering or when you talk about developing a product, everybody wants the moon. And we are trying to see how we can accomplish this in this unique field. Now, definitely the application of tribology should have started with the advent of industrial age, the very first engines, even the steam engines, in the automobiles, where we have several kinds of movements in close contact between them, the several components, the reciprocating movement, rotating, oscillating movements, sliding elements. The energy conversion, these are all basically devices to convert one form of energy into another. When we talk about the heat engines, the thermal energy into finally the mechanical energy. So when we build machines to do this energy conversion, naturally the kinds of machine elements which come into play and their interfaces become important. I was surprised to see, I hope it is right, that in the IC engine, the loss due to friction is almost 50%. I don't know whether it's right or wrong. Now, friction and wear led to our discovery of how to reduce friction and wear, and then what kind of interface elements we had to introduce, like the lubricants, the lubrication. Then the lubrication science and the engineering itself has grown. The type of lubrication, starting from the hydrodynamic and understanding of the dynamics of the lubricant, how it acts, hydrodynamic, electrohydrodynamic, and of course, wherever we cannot apply a fluid system, one talks about solid lubricants and surface protection and surface conditioning. And when we talk about lubrication and lubricated interfaces, one is worried about the effect of environment on their behavior. One talks about definitely one understands that thermal environment is going to be the most serious one, because any chemical or any compound you apply as lubricant, its stability at higher temperatures becomes a matter of concern. Initially in terms of physical decomposition, vaporization, and subsequently in terms of even chemical decomposition. And of course the effect of atmosphere, the oxidation which happens, and then what it does to the lubricant and its behavior. And so we get into the analysis, the understanding of the fundamental action of the lubricant in terms of the physics as well as in terms of the chemistry of the lubricants. Now, we have grown a lot in modeling these things. Today, with very powerful computational tools available, starting from initial rudimentary theoretical model with a lot of approximation, today we can really model up to molecular level how these things, the compounds, are going to behave. The computational modeling has become very strong. And of course, the laboratory studies are also with the kind of instrumentation we have today. The investigation of this phenomena with very sophisticated instruments and techniques have become possible. Well, this is going on. On the other end, like people like us who are working directly in the field and in our organization, when we meet with any problem related to tribology, the field, in the sense where we talk about problem related to a sliding or a rotating or a bearing, there the problem solving mode is adopted through some intelligent guess and then, fix to the problem rather than going for any detailed modeling techniques. This is what is happening today. How to synergize all these three routes: the understanding of physics, the lab studies, and the industrial problem solving. How to bring the communities together and make them work in synergy is going to be a major challenge which the bodies like the Tribology group should address. Now, I am going to my native or the field of strength, which is basically I am an aerospace engineer. So I can only think about talking about the current issues or problems related to tribology when you go to aerospace. All of us are aware the aerospace engines specifically, when we talk about propulsion systems, they are the most demanding part of the aerospace vehicle because they are the prime movers and they are the most complex systems. They handle high intensity, density of energy, and they are if you take any aerospace failure or accident, the propulsion systems play the major candidate. Because of their complexity, they are more prone for failures, and here the role of tribology is extremely important. The kind of power handled in an aircraft engine, if we talk in terms of megawatts, when you come to the rocket engine, you talk in terms of gigawatts, thousands of megawatts, because what's happening in a rocket is basically a controlled explosion, high rate of energy conversion, and the mass which is handled is in terms of tons per second. That's a kind of mass which is converted and imposed kinetic energy and thrown out. Now, when we talk about the machinery which have to work under this environment, especially the rotating machinery in terms of turbines and the pumps, they are subjected to the most severe environment conditions in terms of the high temperatures. And when you talk about pumps, they have to handle fluids which are normally corrosive, toxic, and of high vapor pressure kind of conditions. And how do we handle a rotating machinery with this kind of fluids, and what kind of bearings you will use, what kind of seals you will use is indeed a great challenge, and a lot of work, development work is going on in this. When we talk about high temperature and high surface speeds, what it does to the materials which are in contact moving at high relative speeds, and how do you lubricate them. In fact, the canned motor pumps which handle corrosive fluids, they are having seal bearings, and then they are cooled and lubricated by the fluid itself which it handles. Similarly, when we talk about the recently what we did, the cryogenic propulsion system development, we go to the extremes of temperature. In the combustion chamber, you have 3000 to 4500 K, whereas in the pump you are handling a 20 K liquid hydrogen, and you have a turbine which drives this pump. So on the turbine you have the hot gas side and you have a cold side on the pump, and then these two have to be thermally taken care of, the thermal balancing between the two and not allowing the conduction to boil so that LH2 will not boil. At the same time, the bearings and the seals have to work under this kind of severe condition. Normally the LH2 pumps are the ones which operate the highest speed because the low density of hydrogen to develop head, the speeds involved are 100,000 to 200,000 RPM. That's the kind of speeds what we talk about. And developing bearings and seals for this kind of machinery is indeed a great challenge, and which the tribology specialists are addressing. Now, we also have the conditions of oxidizing and reducing environment when we talk about handling this kind of strong oxidizers and fuels in the rocket machinery. Because we also have direct handling of the oxidizer. Also, there is pre-combusted products which are hot as well as having oxidizing or reducing nature, and the machinery and seals and bearings which come into contact with this kind of fluids. How do we design and how do we develop such elements? Now, there are other launch vehicle functions too, apart from the propulsion system where we talk about rotating machinery. You are all aware when we talk about multi-stage rockets, we are talking about taking a body from Earth and putting it to space at a velocity of 8 kilometers per second, and this is being done by multi-stage rocket. So we do not carry the entire vehicle to 8 kilometers per second. We are jettisoning the spent part of the vehicle as and when that propellant is consumed. So the separation of this various stages, involve several mechanisms which have to act precisely, reliably, and they involve mechanisms like ball lock mechanism, the band clamp mechanism, collet release. In all these things also the tribology and the friction and the design parameters come. But only one redeeming thing here is we can afford to give brute force to overcome some such uncertainties on the frictional forces, because these are only one-time single operation devices. Similarly, before the vehicle lifts off, there are a lot of interfaces with the ground in terms of the hold system, which releases the vehicle only when the full thrust is properly developed. Similarly, the umbilicals, almost a dozen umbilicals, which have to neatly separate from the moving vehicle. Several mechanisms are there where this tribology plays a role. And more than that, when you talk about a liquid rocket, there are hundreds of control components, the valves, the valving elements. They basically involve sliding kind of poppets with very, very close tolerances, where also this kind of the consideration for the friction and the lubrication becomes a very important point. Now, when we go to the spacecrafts and rockets, there are entirely two different animals, in the sense the rocket is a single-use device which does the job in the matter of minutes. In about 15 minutes, we take the object from Earth to space, and then the rocket's job is over. Whereas when you come to spacecraft, a functional spacecraft, as a remote sensing or a communication satellite, it remains in orbit for years, and it has to function in hard vacuum condition. Now, when the spacecraft is first deployed, because it is cocooned within the heat shield of the rocket, it is in stowed condition. As soon as it is released in space, the solar panels have to be deployed. The deployment of solar panels involve mechanisms to release the panels, and number two, the hinged panels with various folding have to cleanly deploy and become a single plane. And in fact, the management of this deployment motion and how those interfaces, the hinges are designed, what kind of lubrication you apply is a very extremely important thing. Similarly, we have several, like antenna deployments, several deployments which have to take place in hard vacuum and space condition. And on board, we have the gyroscopes, which are the inertial reference units, which have to, lifelong, they have to be in spinning condition. We have the momentum wheels or reaction wheels, which act to do the attitude, precise control of attitude by dumping of momentum, which are also rotating elements. And these bearings, these sliding surfaces, they have to survive deep space environment for years together, typically of the order of 10 to 15 years. And today we are talking about refueling satellites in orbit to extend the life to even 20 to 30 years. So the demand on perfect functioning of these kind of rotating machinery, sliding machinery in space continuously for so many years really challenges the tribology area in these mechanisms, and how we are going to develop and validate them. In space, we have the hard vacuum environment, the extremes of temperature. The side which sees the deep space goes to almost 4K, when the side which sees the sun can go to several thousands of Kelvin. Though there is a thermal management on board, the temperatures can sometimes go above the limits, and one has to see how these elements, the hinges and the rotating elements, survive the higher temperature, long duration in vacuum, and the effect of atomic oxygen, because in space we don't have atmosphere, and I read that when the atmosphere is not there, the oxide layer gets quickly removed, and there can be cold welding of metals. So these are the kind of issues when we talk about tribology in vacuum, especially when we talk about the spacecraft systems. Now we go to the further ambitious missions which are already taking place, like the planetary missions. You are all aware of the lunar mission, and today we have sent a spacecraft to Mars. Of course, they are all orbiters, but in our next lunar mission we are talking about landing and then a rover getting released, which is nothing new we are doing. It has been already done by Americans and Russians, and of course China has also done recently. But when we talk about a machinery which has to land in an alien planet and then have the smooth movement and we talk about the environment there. All of you are aware of the moon regolith contains very fine dust. What is its effect on the kind of moving systems, and how we are able to characterize, and then how we are going to qualify the kind of tribology, the elements, tribo elements for that environment is a challenge which we have to now tackle before we plan our landing mission in Chandrayaan-2. Similarly, when we talk about this kind of new missions, one thing which comes to mind is to how we are going to simulate these conditions on ground, to validate our design. And in future, when we talk about a manned mission, today you are aware a manned mission to moon has already taken place long back, but when we talk about missions beyond moon, if you have to go to Mars, a manned mission, naturally it cannot be one way, it has to have a return mission. Then what it is today estimated is that the people who land on Mars will have to produce their own propellant from Mars soil, because they will not be able to carry the propellant for return when they go from Earth. We don't have that kind of big vehicles today. In fact, that is a challenge. Though people are talking about manned mission to Mars, today there is no vehicle which can take you there unless you adopt nuclear propulsion, which will never be adopted because of the eco issues. With chemical rocket propulsion, the size of vehicle you require to go to Mars is just enormous. So one has to have plans of producing from local resources, in situ resource utilization. So the machinery which have to operate in alien planet environment, like moon, on the lunar surface with the lunar habitat, or on the Mars surface, the kind of tribological issues there because of as we saw, the local soil conditions and the dust environment, how we are going to even design them and then how to simulate and validate them on the Earth is the most advanced challenge we can say when we are going to get into that. So the simulation and testing, the environment simulation, and when we come to even our own more mundane things like our aircraft engines or the machinery, how we are able to estimate the life, because the failures, when a tribo element fails during operation, unless we are able to preempt it by proper detecting and health monitoring, failure is always catastrophic, especially in the case of aircraft engines. One can say when an aircraft engine, a bearing fails or a seal fails, the debris itself can cause further damage and can be a catastrophe. So how to estimate the life of these elements, what kind of accelerating testing parameters you can evolve to say that by doing a limited period test, I can assure the life of the engines, and also what kind of health monitoring systems you must embed on board to keep monitoring and preempt this kind of catastrophic failures. These are the kinds of challenges we have. Of course, the lubrication technology, there is a lot of advancement going on. In fact, the material sciences, the kind of development which are happening today, definitely is getting into the lubricant materials also. The inert lubricants, so that to stabilize the chemical actions and active oxidation. Then the solid and vapor depositions to directly deposit on the sliding or rotating elements instead of applying by other means. Powder lubrication and composites. In fact, the composite cages which can contain lubricant, especially in the case of spacecraft systems, we have found that the cages or the reservoir of lubricants, for very minute release of lubricants for years of operations of rotating elements. And of course, ultimately one talks about how to avoid contact by having a gas bearing or magnetic bearing system. But even when we get into those things, still we'll have to worry about the starting and stopping condition when ultimately the interfacing surfaces have to come into contact, and one has to see how to handle that. So what is the immediate future direction in this area? One is, of course, we go on improving our understanding of the physics by modeling using the very, very powerful tools we have today. And also the laboratory testing and the thin loop film technology, which is now being applied for several cases. Then the energy efficient techniques, so that we conserve the energy and the loss is reduced. Surface engineering from tribology angle, and use of smart material and of course the nanomaterials, which gives us several possibilities of enhancing the tribological efficiency. And lastly, we today, like in any other engineering activity, one talks about eco-friendly and green technology applied to tribology, but I do not know whether the quantum of material, the lubricating materials have reached the level that one has to worry about the UCA damage effect, but I'm not an expert in that. So in conclusion, tribology as a specialized discipline has started gaining recognition, but in my opinion, I feel several of us, we feel with just a mechanical engineering degree, we feel that we understand that tribology or the bearings and seals. But I can tell you from my own experience that when we get into real problems in this area, there are not many people who are able to come out with a solution or a proper analysis. In fact, we have to create a database for our own country, with our own engineering industry. Also, we have to develop and evolve this as a separate discipline. Maybe one can think of the tribology as not as just a single group, but then application-specific 2-3 groups which work on various aspects of tribology applied to the machinery and various engineering fields. And in my opinion, it's high time that, I don't know whether it's already there, I see two of the professors from education institutions are here. We need to attract youngsters to specialize in the field of these bearings and seals. Today, when we have a problem in either bearing or seal, we really go around the bush and we don't have a proper approach, especially the people who are working directly in industry with just a basic mechanical engineering degree. So I am sure this type of seminars and conferences will throw open the kinds of possibilities, the interesting and challenging problems, and also give some direction on how to strengthen this field in the coming years. Thank you very much.
Thank you, sir, for shedding light on different aspects of tribology. Now I would like to request our chief guest, Padma Shri Dr. S. Ramakrishnan, Director, VSSC Trivandrum, to release the ICAT14 souvenir by giving a copy to the Director, NITC, Dr. M.N. Bandyopadhyay. Thank you all. Now, may I request our guest of honor, Dr. KBM Namboodiripad, retired professor, NIT Calicut, to felicitate the gathering.
Good morning. I begin with the protest. She referred to me as a guest. I'm not a guest. I am very much a host. I have spent 40 beautiful years here on this campus, and I feel far more of a host than a guest. So please accept my well-meaning, not offensive, but protest. I'm not a guest, I'm a host, part of a host. Having said that, let me be informal. People have already invited you. Still, let me do my part. Dr. Ramakrishnan, our distinguished scientist, our director, Dr. Bandyopadhyay, and my colleagues. I will drop all academic titles and refer to them simply as Prabhakar Nair and Rajendra Kumar and Aleshu and Joy and a number of other people. They have all become very good scientists in their own right, but I will call them only my first name and so on. Well, I have nothing clever or smart to tell my distinguished gathering, but I have a couple of words or suggestions for our young faculty members and students, particularly postgraduate students and PhD students. Please interact with all the faculty members. do not expect to learn everything from the lectures. But lecture understanding is not the only mode by which we improve. Please make sure that you interact with the academic community, build your academic contacts, and that's the way we grow. So we must know all the important people, first to begin with in our own state, and then in India, and then in abroad and everywhere. Over a period of time, please be sure to build your academic contacts. Second, there is a lot of gap between what we teach in the classroom, what's being practiced in the industry. This, a lot of students, perhaps young faculty members, fail to see the link between abstract mathematical theory on the one part taught in the classrooms and the actual down-to-earth problems which are faced by the industry. And people working here do not see why we should learn differential equations. They don't understand, and it's not their fault. And the faculty members who write all complicated differential equations, etc., fail to see, or we are probably the guilty ones. We probably did not give much importance to our students to provide the link between this abstract mathematical theory on the one hand and the down-to-earth real problems. So one of the important missing links that we see in engineering education now is this link. And if you can focus your attention on this, try to relate every time you see this where it's going to be applied. And when you see a problem, if some machine part fails, it does not give a death statement. I'm failing because of fatigue. It doesn't. So it is for us to investigate. And how do we do that? What's the way by which we do this? And unless we do this as case study or project mode, interacting with experts, inviting well-known industrial consultants, sharing ideas, and so on and so on and so on, this will remain as two isolated, compartmentalized knowledge, and that will not be very good for engineering education as a whole. I should not talk for a long time, but I would still urge the young faculty members and students to question. Questioning is not attacking. Ask with humility. Questioning is simply the expression of an open mind, willing to explore other possibilities. I'll quote Rudyard Kipling. He said, I have 6 honest serving men. I have 6 honest serving men. They taught me all that they know. Their names are what, when, where, who, where, whatever. That's it. So it is these. He has drawn attention to the importance of questioning. All the best to the conference.
Thank you, sir. It's not how much we give, but how much love we put into giving. I request our director, Dr. M.N. Bandhopadhyay, to honor our chief guest, Padma Shri Dr. S. Ramakrishnan, with a memento as a token of love and respect. Thank you. I request Dr. M.L. Joy, Coordinator ICAT14, to deliver the word of thanks.
Honorable Chief Guest Dr. S. Ramakrishnan, our beloved Namburi Part Sir, our Director M.N. Bandhopadhyay, Dr. Allesh Head of the Department, Dr. Prabhakaran Nair and Dr. Rajendra Kumar, Coordinators of ICAT14, distinguished guests and invited speakers of the dais, participants from all over the country, delegates from all over the world, faculty, staff, and students of NIT Calicut. Now we are at the concluding part of the inaugural session of ICAT14. It is with great privilege and honor I stand before you on behalf of the organizing committee of ICAT14 with this pleasant duty of expressing my sincere thanks to one and all. First and foremost, let us raise our hearts in thanksgiving to the Almighty for His abiding presence with each one of us. Now let me come to the task. Our honorable chief guest, Dr. S. Ramakrishnan, despite his busy schedule, generously agreed to be our chief guest and came all the way from Trivandrum to inaugurate this ICAT14. His esteemed presence, and I should say the befitting message he conveyed to us, was really inspiring and thought-provoking to all of us. In fact, he has presented a lot of tribological problems. It was worth for a plenary session. On behalf of the organizing committee and on my own behalf, I express my sincere thanks to you, sir. Thank you very much. Our director, Dr. M.N. Bandyopadhyay, is here with us, and he has extended all support for the smooth conduct of this conference. We express our sincere thanks to our director for all his support and for his esteemed presence here. Thank you, sir. I'm indeed glad to thank our beloved Namburi Pat, sir, former professor of the Department of Mechanical Engineering of our institute. He was also the director in charge of NITC for a short span of time. Although he is retired from service, he is still very active and with his academic assignments, and we still have regular contact and interactions with him. He used to inspire every one of us through his messages. Our gratitude to him is beyond words. We thank you, sir. Our head of the department, Dr. Aleshu, has extended all his support for this conference, and I express my sincere thanks to him, sir. Thank you. Although we host this conference as coordinators, I would like to thank Dr. Prabhakar Nair and Dr. Rajendra Kumar, since it is their efforts spanning days and nights coordinating various activities which ultimately resulted into this fruitful culmination. It is hard to find words to thank them. Thank you all the same. Thank you, sirs. Now I would like to thank various keynote speakers, especially Dr. Kim, Dr. Bobji, Dr. Harish Hirani, Dr. Helen Kaleli, especially for their valuable contributions in the form of plenary sessions and all, which is going to come. So they have traveled from various parts of the world and arrived in time yesterday, and they are very much with us now. Thank you very much for all of them. And there are chairs and co-chairs of various technical sessions who have come over here and present. So I extend my sincere thanks to all of them. And also I express my sincere thanks to all invited guests like alumni members and others. Thank you. We have sponsors who have very generously contributed to this conference. ICAT14 sponsors are TechUp, MHRD, DST, KSCST, CSIR, BPCL, Magnum Engineers, SKF Bearing. I think there are representatives from SKF Bearing also present here. We acknowledge their contributions as financial assistance and express our sincere gratitude to them for their magnanimity. Thank you very much. My thanks are due to the organizing committee members, which include faculty, staff, and students of various departments, and I take this opportunity to place on record our heartfelt gratitude to them. It is because of their sincere effort we could bring this conference to this level. On behalf of the coordinators, I thank them sincerely. We thank all the students, especially our PhD students who have taken all the pain to come back and stay here in the campus, especially when the institute is closed. Thank you very much to all. I would like to mention the names of the publishers, technology letters. Through we could publish the proceedings in time, and I extend my sincere thanks to all those who helped us to publish these proceedings. We have people from press who have given sufficient publicity to the conference, and I especially thank them for their presence and reports. We have other people like New Sounds, Kundamangalam, who have made all stage arrangements and light and sound, and there are other people, caretakers of food, etc., etc., and we acknowledge and thank them sincerely. If I have missed anybody, it is not deliberate, and I take this opportunity to thank them all. I shall not prolong further since it is already behind schedule. Thank you one and all. Wish you all wonderful days ahead for tribological interactions and other entertainments. With this, I conclude. Thank you very much.
Thank you, sir. With this, we have come to the end of the inaugural session. I kindly request all the coordinators of ICAT14 to escort the dignitaries of the dais.